All right, so our Pythagorean identity cosine squared theta plus sine squared theta equals 1. Okay, but let's go ahead and let's take that and let's divide every term by cosine squared theta. What is cosine squared theta divided by cosine squared theta? 1. What's sine over cosine? Tangent. Okay, so we have tangent squared theta equals, what's 1 over cosine squared theta? Secant squared theta. And so that's one of your other Pythagorean identities. It was on a test a couple of units ago. But that's how we get it. We didn't just make it up. So now let's go ahead and do the same thing over here, but we're going to divide by sine squared theta. So if you can't remember all 3 Pythagorean identities when you're working this stuff, okay, I even just on my answer key, I had to write it down and do at least one of them so that I remembered it. Okay. So what's cosine over sine? Cotangent squared theta. I know it's been a long time. It's been off for like 3 weeks now. Feels like 3 weeks. Okay, sine squared theta over sine squared theta is 1. And what's 1 over sine squared theta? Cosecant. I also remember because my cotangent goes with my cosecant. Okay, so there's a couple of ways to remember these Pythagorean identities. You guys remember how we got that first one, that cosine squared theta plus sine squared theta equals 1? Yes, no? So our unit circle, right, we have a length of 1 here. So if we draw a triangle, this is my cosine, this is my sine, and this is 1 for my unit circle. It's a right triangle, so how do I find what's my Pythagorean theorem? It would be cosine squared theta plus sine squared theta equals my hypotenuse. Okay, so that's how we got that Pythagorean identity. That'd be nice because you guys won't have to memorize all these Pythagorean identities. I'll just give you guys all right. So we're going to be doing proofs, our guidelines. We're going to work one side of the equation at a time. It doesn't matter which side you start with, but usually start with the more complicated side because sometimes you do not have to work both sides. Okay, one of these is pretty complicated today, and we will have to work both sides. Look for opportunities to factor, add fractions, square a binomial, or create monomial denominator. So if you separate the denominator out, okay, and if you have cosine over it, you can put 1 over cosine and secant or sine over cosine, so you can separate them. Okay, fractions. The other thing that you might want to look for is to multiply by a conjugate. Okay, so sometimes you might have to multiply by a conjugate. So remember, a conjugate would be if I have 1 minus sine of theta, my conjugate would be 1 plus sine of theta. Okay, so I would multiply both the top and bottom by that. Okay, just like with imaginary numbers and rationals. Sometimes I want to do that. I like this stress, but try not to show my. Okay. So we want to look for opportunities to use fundamental identities like secant, cosecant, cotangent. And if stuck, we always want to try and convert back to those fundamental identities or to sines and cosines. Sometimes when I'm working these, I hit a dead end and I erase it and then I have to do something else. Okay, so because there's multiple ways to work it, but some make it harder than others. So sometimes I get to a spot and I'm like, ooh, this looks really nasty. Let me try something else. Okay, so it's okay if you make mistakes and you need to try something else. Okay, and we're going to work up. Today's worksheet is pretty basic. And then tomorrow it's going to get a little more difficult. And by Thursday, it's going to get very difficult, except on Thursday, we're going to be doing it together. Okay. So like, you guys will have, I got all new dry erase boards and markers. I'm so excited. So you guys will have dry erase boards, and we'll be working it together. I don't know, maybe I'll have you do it on the worksheet. I don't know. How do you do that? Whiteboard. Yeah, whiteboards, but I want you guys to be able to refer back to, I guess I'll video it, I'll record it so you guys can post it so you guys can see it.
I'm going to pass the whiteboard.
All right, so we're gonna verify each identity. In other words, we're gonna do a proof and prove that one side equals the other. Okay, so I see tangent squared theta plus 1 equals secant squared theta. Which side do you think is the more difficult side? The left side. It looks more difficult. So I need to change that to something. What can I change tangent squared theta to? Plus 1. What's tangent squared theta plus 1? Ah, there we go. It's secant squared theta. That means they're equal. Yeah, and sometimes I'll write the equal sign and write them out. Sometimes I just put it there. Okay, that's it for that one. Okay. So we just have to change that. Go ahead and do the next one. Yeah, you have to do just a little bit of finagling. Okay, so we know that cotangent squared theta plus 1 equals cosecant squared theta. Okay. So we might have to rearrange that a little bit. So we need both sides to match. So if I'm rearranging this Pythagorean theorem or this Pythagorean identity, what do I want to get by itself here so that it matches? Yeah, I need to move the 1. So minus 1, minus 1. So if I do cotangent squared theta equals cosecant squared theta minus 1, oh, look, that's what I have there, isn't it? No, because it was plus 1, right? So I'm subtracting 1 from both sides.
There's minus 1 and 0.
To get the cotangent. Yeah, I know. I'm not looking at that right now. All I'm looking at is my Pythagorean identity. Yeah, you can do that. You could have 1 to both sides here. That's fine. Okay, but we want to try to work just one side at a time. Okay? So either way works. If you added 1 here, right, you would know that that's cosecant squared theta. And then you would have cosecant squared theta equals cosecant squared theta. Okay, so either way works. So here we know that cotangent squared theta equals cotangent squared theta, or if you add it. Okay, like I said, there's multiple ways to do this. Okay, find the easiest way for you and do it. I always look for the more difficult side and just work that one side. Because once you start moving stuff from side to side, then it starts getting hairy, especially as we move on to some of these more difficult ones. Okay. Hello, you good?
Yeah.
Okay. Zero lesson spirit. All right. So this one says sine x plus cosine x squared equals 1 plus 2 sine x cosine x. Well, looking at this, I don't know what to do with this yet. We will in the future, but not yet. We don't know what to do with that. Well, this one I can do. This one means sine x plus cosine x times its squared sine x plus cosine x. Binomials. How do we multiply binomials? Oh, FOIL. Good. So we're going to do our first. So that's going to be sine squared x. Then we're going to do our outer. So that's going to be plus sine x times cosine x. And we're going to do our inner. Don't worry about that right now. So that's going to be cosine x times sine of x. And then we're going to do our last. So that's going to be plus cosine squared x. I see something in there that's an identity. You guys see the identity that's in there. Remember, we're adding stuff, so we can move it around. What do you see? Yeah, add those two together and you get 1. Right? Plus, well, what about these two? Cosine x times sine x and sine x times cosine x. Are
Aren't
those
they the same thing?
They are the same thing, exactly. So we can add those together, so there's 2 of them. Oh, look at that. Those 2 sides match. Anna, did you need me to seal your letter and put it like in an envelope? Okay, I'll do that for you. I thought of that over spring break. I don't care if you read it. I won't write a letter, but I'm not a good student. All right, so sine of x equals cosine of x over cotangent of x. I start with the more difficult side, sine of x. I can't do anything with that, right? It's sine of x. So let's do the more difficult side. What do you think I should change first? What can I change? Almost. What is cotangent? Which is in sine and cosines, right? What is it? Cosine over sine. Okay. So let's go on ahead and rewrite this. That's cosine of x over cotangent, which is cosine of x over sine of x. I'm dividing by a fraction. Do I ever divide by a fraction? No. What do I do instead? Multiply by the reciprocal. So that's over 1. So what happens there? They cancel. Yeah. The cosine and the cosine cancel, right? I'm left with just sine of x. No way. Oh, they're the same thing. That's so cool. Mind blown. Right. There we go. All right, they're looking a little more difficult. All right, so cosine x over secant of x plus sine x over cosecant of x equals 1. Okay, well, I see some cosines and some sines. Remember, all else fails and you don't know what to do, change everything to sine and cosine. So what are we going to do first? We're going to change secant to what? One over cosine of x plus sine of x. What is cosecant of x? Good, 1 over sine of x. But we never divide by a fraction. What do we do instead? Multiply by the reciprocal. So it's going to become cosine of x times cosine of x over 1 plus sine of x times sine of x over 1. Oh, what did I just do? Yeah, I did. What's cosine of x times cosine of x? Oh, this is going to be cosine squared x, right? Plus sine of x times sine of x, sine squared x, which equals 1. Which is what we were looking for. And this next one, we're going to be dealing with both sides. Okay, but we're going to start with one side and then we'll move over to the next side. Okay. All right, so I have 2 fractions with different denominators, and I need to add them. So find a common denominator. So here, what's my common denominator? Secant of x plus 1 times secant of x minus 1. Okay, so if I multiply this up here, I get secant of x minus 1. Okay, and then I'm going to multiply this one up here. Do you guys see what I'm doing without writing it all out? So I'm actually just finding that common denominator by multiplying the top and the bottom, okay, by the opposite denominator. You guys see good, Hunter? You guys understanding? So if I have like 2 over 3 plus 3 over 7, I have to multiply this by 3 over 3, and I have to multiply this by 7 over 7. Instead, I'm just drawing my little arrows and knowing that I have to multiply that. Okay. All right, so I have secant x minus 1. I'm going to multiply this one. I'm going to get plus secant x plus 1 all over secant x minus 1 times secant x plus 1. Doesn't matter which way you write them. I'm multiplying it anyway. These are where memorizing some of your rules come in handy. Okay? Some of your just basic rules for FOILing. And -1 plus 1, those cancel. So what am I left with up top? Secant squared x. All right, now I'm going to multiply these binomials. And if you'll notice, these binomials are in the form a minus b, a plus b. So what should that equal when I finish?
A squared, A plus, maybe.
Remember we usually do that backwards? Okay, but if you memorize that formula, then you can go on ahead and know, oh, I don't have to really multiply everything out, okay, because they're conjugates. Yeah. Yes, yes, sorry. Thank you. Thank you, thank you. Yes, that should be 2 secant x. I got ahead of myself. All right, thank you very much. All right, so now let's go ahead and multiply this. Okay, and we're just going to multiply our first 2 terms. Okay, we get secant squared x, and you can FOIL it if you want. It's going to cancel. Okay, but if you remember those rules, it really helps. Okay, minus 1. It's a difference of squares. What is secant squared x minus 1? The tangent? The tangent squared? Yeah, tangent squared, right? I have 2 secant of x over tangent squared x. All right, well, what is secant? Secant is 1 over cosine. Tangent is what? Sine over cosine. I never divide by a fraction. I always multiply by the reciprocal. I'm going to multiply by cosine squared x over sine squared x. One of these cancels with that one. And what am I left with there? 2 cosine x over sine squared x. Well, what is cosine over sine? Cotan, right? So I can take one of these cosines and sines, and I get 2 cotan x over sine of x. That's all I can do with that side. Okay? Does it look like the other side? Nope. So now we're going to work the other side. All right, so 2 cosecant of x over secant of x times cosecant of x minus cotangent of x. Okay, sorry, that's more space. Probably on the bottom or the back or something. All right, So, so let's change this cosecant of x to 1 over, it's going to wind up being 2 over sine of x, all over. Let's change all of these to sines and cosines. So secant of x is 1 over cosine of x times 1 over sine of x minus cosine of x over sine of x.
So if we have a test next week or next time, I have it, and after that.
You're not going to have a test. It's going to be your,
Group.
it's going to be a project. Yeah. So that's week of week. And then after that, we'll do chapter 5, and then we have limits. I think we have enough time to do all that.
We have group test line.
Well, yeah, the project, and then chapter 5, and then limits. Yeah, we probably, I don't know if we'll do a final or not. It depends. I mean, we're like algebra 2, boy, we're having to cut chapters left and right. So we haven't had enough time to, every time you come in, we have to go over factoring again, factoring again, factoring again. We had to cut statistics
Let's go like that class.
in algebra, no, in algebra 2, the statistics chapter, which a lot of students really like, but it's not important for calculus. And if you go into statistics after that, then they go over it all anyway, so. We're gonna make it. All right, so now I'm gonna go on ahead, I need to get rid of something in the denominator. So I'm gonna get rid of this cosine of x. So I'm gonna multiply the top by cosine of x over cosine of x, and I'm gonna multiply the bottom by cosine of x over cosine of x. Okay. All right, so here, this one's gonna cancel that one out. So now I'm going to be left with cosine of x minus cosine of x over sine of x, cosine of x, sine of x, cosine of x. Oh, I lied, didn't I? Anyone see my lie? That one went away. Over. Oh, I just accidentally threw that too, right? Oh, yeah. So I'm just multiplying the top and the bottom by cosine of x over cosine of x. That's it. All right, so now this becomes, the numerator becomes 2 cosine of x over sine of x times cosine of x, all over. So here, that's a square. So I have cosine of x minus cosine squared x over sine of x times sine of x cosine of x. And yeah, this one's getting a little nasty, right? And what did I do here? What did I do? Anyone see what I did? Oh, this should be 1. There we go. What I did? This one's nasty. With which one? So I got 1 minus sine of x. Well, so this one here. Yeah. Well, it would, let's see, it would cancel one of those, and then you would just be left with cosine. What did I do? See? Sometimes I get stuck too.
Wouldn't you not even need to multiply that?
Minus cosine squared x over sine of x. What did I do here? How did I get cosine of x?
Oh.
because you're only multiplying the two, and then you're subtracting one of them.
Yeah,
It becomes a little.
so it should be cosine squared x over sine of x once they cancel. Yeah, so that's right. So that one cancels. Okay. All right. So let me erase this.
And then it would just be cosine x.
Yeah. So cosine x over sine of x. Okay. So now we have 1 minus, that's minus and that's times. What did I do here? I don't either.
You're subtracting the first one.
Hold on, I multiplied wrong. Hold on. Am I subtracting? Yeah, there's that. Sorry. This one was one that I had to look at a couple of times. Because this, like I said, even I have to look at them. All right, so cosine 2 over sine of x, 1 over cosine of x, 1 over sine of x, minus that. I'm going to multiply by that. I get 2 cosine of x over cosine of x. And I get here, that cancels to 1 times that cosine of x. Next cosine of x, next sine of x, and that cancels to that. Yeah, well, I even wrote it wrong, but it was so chicken scratchy that, you know. So I got that over that. I don't like this one. Now, cosine of x, right, over sine of x. Oh, that's because of the whole thing. Okay, that's fine. That's what I did. All right. All right, hold on. Sorry. All right, so when we multiply here, we're going to multiply the whole thing by cosine of x over cosine of x. So now what that's going to turn into is 2 cosine of x over sine of x. Because we're multiplying just the whole fraction. So really it's going to be cosine of x over 1 and cosine of x over 1. Okay? Because we're just multiplying by the reciprocal. That's what I did wrong. Okay, sorry. Okay, so now that's going to cancel. And that's going to equal cosine of x here is going to be, let's see, cosine of x over sine of x. That cancels. And then we have minus this right here. Oh, that cancels. The 1. Okay. So that cancels. So that's good. So we're left with that minus. Okay. Now we have cosine squared x over sine of x. There we go. Okay. All right. So I just wrote it as cosine over cosine. It should have been the reciprocal. And we're multiplying by the reciprocal. Okay. And everyone see what I did here? So I multiplied this by cosine of x over 1, and I multiplied the entire denominator by cosine of x over 1. And Giselle, do I got you?
Yeah.
All right. Sorry. All right, so now we're here. So these are the same, right? So let's go ahead and combine them. So we have 1 minus cosine squared of x, which is really what? Sine squared x, right? And so we have 2 cosine of x over sine of x over sine squared x over sine of x. What's cosine over sine? Cotangent. So we have 2 cotangent x over, we can cancel that. And what are we left with? Sine of x. Okay, and that's what we wound up with on the other side. Okay, so they really do equal each other. Okay, I'm not going to give you guys one this difficult, but it's always fun to work on. Okay, and this one, I tell you, I erased a couple of times and I was like, what am I doing? Okay, that's why I would never get it to you guys. Yeah. On the test.
You have 1 over sine x denominator?
Uh-huh.
Did you just not multiply that one? by-
Well, because this is multiplied, right? So when I multiply this, it cancels this out and it doesn't affect that.
Oh,
Okay, that's why. Yeah,
What exactly is this used for?
so once you get into calculus, you're gonna be doing differentiation and integration, and you're gonna have to know how to manipulate these. So this is all manipulation of different functions. Okay, and then we're gonna get into our additive properties. So we're gonna get into our sum and difference identities, our additive properties, and our double angle formulas and stuff. And that stuff all relates to your higher level calculus classes. Okay, so this is, it's all, like I said, just, it relates to that upper level calculus. So you guys, I'm not gonna give you guys one that's difficult. I would never, ever do that to you guys. I might give you guys some that are a little difficult. Okay, but that one was pretty nasty. And I did it at like 3 o'clock in the morning the other day because I couldn't sleep. So. You know, a little more. All right, so I'm gonna give you guys a worksheet. Okay, it's 12 problems, proofs. Okay, they're not terribly difficult. We are gonna grade this at about 9:20. That way you don't have anything to worry about tonight. Oh, is it still 4.1? Yeah, you guys, we should probably finish our 4.1 notes. I, for some reason, thought we were done. I don't know. I'm sorry. I don't think that there's any of this on here, though. I think I put that on the next one. Let me check. Let me check. Are there any solid differences on here? I think that's on 4.2. No. There's no sum and differences on this, so we will do the rest of 4.1 tomorrow. And 4.2, I don't know why I did whatever I did, but. So just instead of X, right? Instead of X, sometimes there's thetas and betas and, you know, different things. Let me check my worksheet for tomorrow. I think my worksheet for tomorrow has this stuff on it. Let's see, where's my worksheet for tomorrow? Why are there different names for angles? What? Yeah, tomorrow's worksheet, I put all the rest of 4.1, so we'll just wait till tomorrow. Hey, Giselle, do you want to stay on in case you have questions?
I can't do the